Hi, I'm Joe Moniotis, and welcome to the Critical Tech Podcast. Today, we're going to talk about the massive opportunity to convert bio waste, into drop-in fuels. I'm joined by Mike Paszti, the Chief Operating Officer at Carbon Critical. Welcome, Mike.
Thank you, Joe. Glad to be here.
Excellent to have you. And let's get right into the topic of today, and that's the massive opportunity to replace fossil fuels with biofuels and e-fuels to reduce carbon emissions and promote sustainable energy production. Now, I just want to start with the difference between fossil fuels and biofuels in general. If you could just speak a little bit on that, because that's really interesting. Um, you know, an interesting topic and an interesting place to start.
Yeah, I wanted to give you an answer that was a little bit different than what's typical out there, but effectively, fossil fuels are sequestered carbon underneath the ground and in the earth. And when we burn them, we're taking that carbon that was once happily tucked away and releasing it into the atmosphere, which is bad for global warming. It's bad for the environment. Whereas biofuels, you're using carbon that exists, it's in circulation already in our ecosystems, in our atmosphere. It's carbon that's in plants. It's already going around and around in a circle and a cycle. So we're taking that carbon, using it, it burns, and then it goes back into plant life or other organic matter. So it doesn't add additional carbon to the environment.
All right, so that's excellent. Now, what I'd like to delve into next is this concept of waste to fuel. Tell me a little bit about that.
The waste we're talking about is biogenic or organic plant matter, food waste, things that once grew or once were consumed as food or something like that, maybe even pulp and paper from from trees. So uh, by taking this material that is effectively organic and decomposing, nobody wants it. In fact, there's a cost to disposing of it. And if you don't dispose of it properly, it releases methane and CO2 into the atmosphere. That's bad. So there's a double benefit to taking waste and turning it into a fuel. I'm dealing with a waste problem that emits methane potentially, and I'm creating a fuel that replaces fossil fuels. So double benefit and double revenue streams, I might add.
It sounds really exciting. One of the big questions that obviously comes to my mind is why aren't we doing it now? Or what do we need to do to actually do it?
No, it's a great question, and people have tried and many have failed because if a waste is that valuable and useful and easy to use, then it's no longer a waste. It becomes something that people buy and pay for. Um, but the other problem is that most wastes are just really hard to use. They're full of water. Organic materials tend to have lots and lots of water, and they tend to be very contaminated. Organic waste, that is, tends to be very contaminated. It's not one thing; it's a million different things. If I look at what's coming through the sewer system, for example, that's got everything from every kind of waste you can imagine, from your kitchen sink, from your bathrooms, whatever. But then it also has little bits of dirt, chemicals, pharmaceuticals, you name it, batteries, everything gets flushed down the toilet. So, it's not an easy to harness material. So to make that viable and cost effective, you need to have technology. And you also need government incentives to help and mandates and other things to make it worthwhile taking this very complex mixture and turning it into something useful. The thing that's changed over time is technology's improved, but we've also recognized as a society that um, we can't just be doing status quo. We have to displace fossil fuel. We have to responsibly dispose of waste. And technology and government incentives and environmental regulations have made that a viable opportunity now.
What would the infrastructure look like? Like, what do we need to do? How do we need to upgrade existing infrastructure? I want to get back a little bit to the technology that's needed to get this done, but I want to sort of start with a broader scale and move down to that. So let's talk a little bit about infrastructure.
So there's infrastructure that deals with the waste today. And fortunately, modern society has created really wonderful infrastructure. We don't have, open sewage pits. We have everything piped to treatment centers and treatment plants, by and large. So, that's good. The waste is already coming to one place. The trick is now, can we take this very wet waste and do something with it? And what Carbon Critical, its real magic is that it's able to take wet waste. In fact, it needs wet waste to process properly. it uses that water content as a tool rather than it being a detriment and a difficulty to process the organic waste. So our technology, it takes that water and helps react it with the organics in the wastewater, and thereby creates the fuel at the same time creating clean water that has all those nasty chemicals that we associate with like pesticides, for instance, dioxins, PCBs, anything and all sorts of PFAS. That's a very common and well-known chemical associated with Teflon. Um, those get destroyed at the same time. So, we're cleaning up waste, like I said, and then we're making fuel out of the organic components.
So I was getting to that, and that's really exciting. Tell us a little bit about carbon critical technology and what you're working on. And we've seen some early success. And so tell us a little bit about that.
Yes, we have. So by taking this very wet mixture that's 85, 90% water, this is the sewage that's coming down the pipe to the waste treatment plants. By taking that material and treating it at supercritical temperature. Supercritical is, for the layman, very high temperature, very high pressure. So the water becomes another state of matter. It's not liquid, it's not gas, it's this kind of weird, in between phase that has vastly different properties than water as a liquid or as a gas. And it's able to break down organic materials into bio oil, which then we further refine through various processes into what they call drop-in fuels. Drop-in fuels directly replace diesel and gasoline. They go right in the tank, no modification to the vehicle necessary, no modification to the fuel infrastructure or the fuel complex, drops right in, plug and play. So that's kind of the trick here. We're taking this very wet material, very difficult to use waste, chemical reacting it with the help of supercritical water, refining it, creating fuel.
Let's talk a little bit about the numbers in, say, a city or a municipality or something like that. What sort of numbers are we talking about in terms of how much of the feedstock there is, how much fuel could be produced, that type of thing? We talk theoretical in general, but just to give people a sense of how how lucrative this could be for the transport industry, for example, and also the local governments and municipalities and the like.
Absolutely. Now I just want to sort of set expectations a little bit here because as a society, we use a inconceivable amount of fossil fuel and just fuel in general. Um, it's the numbers just would blow your mind because we're talking about billions of gallons a year for a small country. I mean, the hundreds of millions of barrels of oil they produce every day and week and is an overwhelming amount. The kind of now, fortunately or unfortunately, we also produce billions of gallons a year of or billions of liters a year of wastewater from municipal systems, from households, from business, and everything. And that is an enormous stream of material that has to be dealt with. And when you convert that to fuel, it's a really notable amount. It's something that a small business could or a company producing this fuel could certainly survive on. And this is very green fuel too, so it actually has a premium in the market. Uh, but in the grand scheme, it's not going to displace all the fossil fuel we use. There's no way. Um, Billions of gallons of very wet waste is not going to make the trillions of gallons of fuel that we need. So it is, in a sense, a small percentage, but it's an essential percentage that we need to make because A, it's very valuable fuel, and B, we're dealing with that waste problem more responsibly. Uh, if everybody's looking for the magic bullet that's going to replace all fossil fuel, there is no solution on Earth yet. But this is an essential component of it. We need to take that waste. It's sitting right there. We got to deal with it. Well, let's turn it into fuel, and it's a profitable solution, frankly. So let's do it because it just makes sense.
Yeah, that's good to know. I wanted to swing back to the technology at Carbon Critical because I think exactly what you said, that it is a small but vital component and it deals with two problems at the same time. So doubling back to the technology at Carbon Critical, uh, what stage is it at, and what would you need to get to industrial scale? And I want you to answer this question on multiple fronts, including government policy incentives and obviously industrial changes that are necessary and that type of stuff.
Absolutely. I mean, it goes without saying that when for small business and for the kind of R&D you need to do to advance the technology, government support through grants, government support through policy needs to be in place. The grants, those are forthcoming. They're happening right now through various agencies, ARPA-E, DOE, National Science Foundation. There's all sorts of grant opportunities. Could there be more? Absolutely. Who's going to say no to that? Uh, and on the policy side, well, there's already renewable fuel mandates. We've, that started a long time ago under Republican presidency of George W. Bush. So, over nearly 20 years ago. So, that's starting. That's when I say there's a premium for this low carbon or no carbon green fuel we make, it's because of that policy. It's called the Renewable Fuel Standard federally in the US. In Canada, they've got their own standards in virtually every country, Western country, Eastern countries, whatever. They've got some kind of standard there that's encouraging the use of renewable fuel. And then on the state level in the United States, you've got very strong mandates, particularly in California, low carbon fuel standard, and that encourages low carbon fuels, and you get the manufacturer of these fuels gets a huge premium, double, triple sometimes, depending on how low carbon that fuel is. And then when we talk about the technology, well, we've put money into pilot scale testing. We've got some larger scale equipment that we've already constructed, and we've had very successful test results based on the waste we've processed. And where does the investment come in, or what do we need? Well, to accelerate our growth and build that pilot plant, uh, investment's required. So nothing happens without investment, and that means investors. That means a little bit of risk taking, and but nothing ventured, nothing gained. We need this kind of growth. The earth needs it, and economically, just makes sense because this waste is not going away. There's more and more of it. There's one thing you can rely on, whether there's a recession or no recession or whatever. We have a lot of waste we generate as a society, and there's a day of reckoning coming. It's getting harder and harder just to throw it wherever we want. We've got to dispose of it responsibly because we're creating greenhouse gas emissions if we don't.
Mm.
And simultaneously, if we don't displace the fossil fuel we're using, we keep creating greenhouse gas emissions. And I don't need to tell you that global temperatures keep rising, and frankly, it's getting tired every year. You hear the news story about, oh, this year broke another record, or the last 5 years were the
Mm.
highest on record. It just keeps happening over and over, and that pattern's going to continue.
If you were to, in say a couple of minutes, um, give us a roadmap to getting this done, what would it look like?
If you mean get rid of fossil fuels and decarbonize the economy, I can give you a high level roadmap of what that looks like, and it's not going to be fast. So I did say that our fossil fuel consumption is uh, eye-wateringly huge, and that doesn't go away instantaneously. But if we do step by step, we start taking out uh, displacing more and more of that fuel every year through the renewable fuel mandates, through alternatives like creating fuel from waste. Uh, we will slowly decarbonize the economy. At the same time, you've got technologies like battery technology rapidly improving. So we're electrifying more and more of the economy. We've got renewable energy generation, such as solar panels and wind turbines, and stationary energy storage, which is kind of the missing component there on the electrical side. But that's going to slowly displace fossil fuels and natural gas power generation, certainly coal generation, um, in time. So that's all happening at the same time. So it's really many things happening that are going to decarbonize the economy. And what we do, it's called carbon critical for a reason. Carbon critical because we do a critical task of removing carbon from uh, fuels and other parts of the environment. So um, that's kind of the big picture, and it's a generational project. It's not going to happen in my career. It's not going to happen. That's going to certainly not going to be finished in the next 10 years. But we have to take the right steps in the right direction. And if anything, and most certainly, we're going too slowly. I'm just gonna go on a little bit of a tangent here, but do we all remember um, the documentary, Al Gore's documentary, An Inconvenient Truth? It's scary to think that that was 20 years ago, nearly. So, what have we done in that 20 years? Probably not as much as we thought we could have. It seemed like a very urgent issue back then, and we've taken, I'd say, modest steps. Society looks a lot like the way it did back then. It hasn't changed a whole lot. So, we're heading in the right direction, but probably need to go a little faster. So, in a solution that makes sense like ours, where you're taking a problem and solving one problem and solving another problem at the same time, disposing of waste and creating a renewable fuel, it's wise to kind of jump on that and get the investment flowing into it and get it done.
And in terms of the piece of that roadmap that involves waste to fuel, what needs to happen there to maximise the that process, or what we can get out of that process?
So I would say two things. There's the investment through private means, public means, government means in our technologies, and at the same time, enforcing or creating rules that don't allow organic waste to be disposed of haphazardly. Because when you dispose them improperly, they emit methane. Methane is a very strong greenhouse gas. In people tend to say it's 25 times worse than CO2. Well, actually, it's 100 times worse than CO2 if you're looking at a 25-year time frame, not a 100-year time frame. So it's important to kind of methane's a really terrible greenhouse gas, and we can actually do something about it. It's just that when people seem to get upset when they're not allowed to just throw things in a landfill anymore. We know that's not a good way to dispose of organic waste. We know it creates methane emissions. Let's just do something about that. Let's just stop it. Harness this waste for the resource it is. And what better way to harness it than to turn it into renewable fuel that displaces fossil fuel? It's a great solution on both ends.
Mike Paszti, it's actually been a real pleasure talking to you and learning about this stuff. And obviously, we do this work behind the scenes, but it's nice to really put it down in a conversation that is one for the ages. Thank you so much.
Thank you. Let's do this again.
Now, before I let you go, first tell us a little bit about yourself and give us your environmental message to society.
For one reason or another, I've been in the sustainability space for my whole career. I started off in biofuels, um, did waste to fuel, like organic waste to fuel. I did battery recycling, hazardous waste disposal, like always something about the environment, and it always involved harnessing a waste and turning that waste into something useful. Um, and it wasn't really a plan. I don't think I'm a brilliant career strategist, but that's the way it worked out. And it always mattered to me that I was doing something worthwhile, and that's worthwhile, not just from an environmental sense, but from a business sense, because you can't have environmental sustainability if you don't have economic sustainability. So that's kind of been the driving force. I always got a kick out of taking something and transforming it. I'm a chemical engineer. Chemistry is the closest thing to magic, taking something that looks like something and turning it into something totally different that has actual use. That's kind of what I live for. So that's a bit of my sort of personal view on life. And I think taking I mean that's exactly what business is as well, taking something that's low value and creating high value from it. So my environmental views and my desire to make a living seem to mesh pretty nicely. And I think if we take that same mindset and we do things that seem to have that look like they'll have economic viability, such as taking waste and addressing that waste problem and creating fuel at the same time, I think we're on the right path. And that's really been the last 20 years of sort of becoming more sustainable as a society. We've tried many things, and some were frankly very stupid. But slowly, you know, the market has sort of decided that, some things make a lot more sense than others. And that's why you see the rise of electric vehicles and battery manufacturing, this huge investment. I mean, the Chinese get it. Like they're crushing us. They're crushing everybody in terms of electrification, battery manufacturing. And also the renewable fuel side of things. We're making fuels that, they started off with these first generation fuels, which were great, but now we're talking about sustainable aviation fuel, drop-in fuels. We found a way to economically transform things into drop-in fuels as opposed to these kind of, blend stocks that you can't really drop in all the time. Um, so slowly we're getting to the right place, and I think we just got to keep on the same path we're doing. I mean, we try a bunch of different things and see what works, what makes sense, what we can afford. But if anything, we got to go a little faster. I mean, this has been a very long journey, huge part of my career, and unfortunately, it's not going to be done by the time my career ends or even my life ends. So, you know, we got a lot of work to do. I think the younger generation gets it, and people are feeling it, and you see it from receding glaciers to ski seasons that are turning into, weeks long rather than months long. Incredibly hot summers. It's time to do something. And I think, people slowly are going to get it. Unfortunately, the people that suffer the most are going to be people near coastlines that are far from North America and the West. So the message may take a little time to get to the West, and we need to accelerate what we're doing.
Excellent. Mike Paszti, thank you very much.
Thank you.